The story of the birth of our universe is a profound puzzle, and contemplating what existed before it adds another layer of complexity. Scientists, in their pursuit of answers to these monumental questions, have made significant strides. Let's delve into what they have uncovered so far. The turning point came in the 20th century thanks to the work of Edwin Hubble. Positioned on Mount Wilson in Southern California, Hubble aimed his telescope at the heavens and made a groundbreaking discovery. Those seemingly haphazard clouds of gas were, in reality, other galaxies, numerous and widespread. However, there was more to this revelation. Hubble discerned that these galaxies were not static, they were in motion. This observation carried immense significance. The movement of galaxies indicated a fundamental truth: the universe is expanding. The logical implication is that if the universe is expanding, it must have had a starting point. This realization marked a turning point in our understanding of the universe. It posed a profound question: what was the origin of the universe? The answer seemed to lie in running time backward to pinpoint where it all began. Edwin Hubble's work was a crucial step in unraveling the mystery of the universe's birth. Absolutely, it's a fascinating journey into the heart of cosmic origins. So, after the groundbreaking observations by Edwin Hubble, scientists delved into many more years of contemplation and experimentation to give us what we now call the Big Bang Theory. And here's the crux of it: before the Big Bang, there was no where or when. It's a bit like trying to pinpoint the location of dreams before you fall asleep. But hold on, there's a twist: the cosmic singularity. This is the state of our universe where it was mind-bogglingly small, incredibly dense, and blisteringly hot. Picture our expansive universe compressed into a tiny, compact ball. The pressure and temperature inside this cosmic kernel reached staggering levels. At some point, it became impossible for this compressed state to endure, and voila, the Big Bang happened. The Big Bang was an explosion of energy and matter, the cosmic fireworks that birthed everything we now perceive: time, space, the fundamental forces governing our reality. It also scattered quarks, those tiny building blocks of our world, everywhere. Think of them as minuscule particles, all simmering in an intensely hot cosmic broth. As things cooled down, gravity entered the scene, pulling these particles together. They gathered into atoms, then molecules, setting the stage for the emergence of the first celestial entities, stars. And all of this unfolded just a blink of an eye ago, cosmically speaking, around 12 to 14 billion years back. Quite the tale, isn't it? Alright, so now we're in the loop about how our universe came into existence, but what's the scoop on what happened before that? Alan Harvey Goose, an American theoretical physicist and cosmologist, dedicated his life to unraveling this enigma. After diving into the Big Bang Theory, Goose spots some hiccups. Take the distribution of matter, for instance. It's oddly even when it shouldn't be. Let's paint a picture here, quite literally. Imagine a balloon loaded with paint hanging from the ceiling, a crisp white canvas on the floor. Drop the balloon and you'd expect a canvas in chaos, right? Splotches going every which way, none looking like the other. But hold up, that chaos isn't what the universe resembled. Instead of tossing a colorful ball from the ceiling, let's start with a tiny red dot on the canvas. Now let's zoom in frame by frame. Voila! A circle slowly blossoms in all directions. That's the real deal: the early universe, uniform and proportional. Goose's revelation, the theory of inflation. Here's the gist: before the Big Bang, some powerhouse force was in play, a force that could jack up the bang's acceleration. Something that could instantly and evenly distribute everything in space. Goose's theory struck gold, and now most scientists are on board. For many, this explanation of the universe's birth is the bee's knees. But, of course, there's always a maverick. Meet Martin Bojewald, a German physics maestro. According to him, the universe didn't just pop into existence from some cosmic singularity out of the blue. Nah, that's hogwash. So, where did it come from? Let's keep peeling back the layers of this cosmic mystery. Imagine a pendulum on an old clock, swinging back and forth with its movement so smooth, continuous, and never-ending. That's the way we usually think of time, right? A seamless flow that never hits pause. But hold your horses, enter quantum time. Oh yes, quantum time doesn't play by those rules. It's more like the second hand of a clock, ticking in small segments and taking short pit stops. And just like the clock, when one segment begins, another bids adieu. Catch my drift? Now, back to balloons. According to the Big Bang Theory, once upon a time, our universe decided to go big, inflating like a balloon. But here's the kicker: sooner or later, that cosmic balloon is going to deflate. The universe will start contracting, heading back to the cosmic singularity state. And guess what comes next? Another Big Bang. Because, nothing pops up out of thin air and vanishes into the void. Now, according to Bojewald's theory, the beginning of each universe spells the end of the previous one. Our universe isn't the first or the last, there were millions before us and millions will follow. Now, this theory, while sounding all logical and intriguing, is still a bit like a puzzle missing some pieces. Unfortunately, we don't have all the knowledge and evidence to stitch it together completely. So, for now, it's all just a hypothesis, a tantalizing idea waiting for more cosmic clues. But some minds out there are cooking up even stranger ideas. We're talking about scientists who are championing theories so unusual they make your head spin. Enter Turok, a South African physicist, and his partner in cosmic musings, Paul Steinhardt, an American theoretical physicist. These folks aren't just thinking outside the box, they're throwing the box out of the galaxy. Their proposition? Brace yourself. Our universe isn't a solo act. Nope, there's been an infinite number of them before and will be after. And wait for it, it's not just an infinite loop of Big Bangs. Our universe is just a tiny speck in a sprawling collection of infinite others. Picture this, we're trapped in a cosmic recycling bin, bouncing between parallel worlds in a never-ending cycle of rebirth. Sounds mind-bending and a bit spine-chilling, doesn't it? Now, let's try to unwrap this theory. According to these cosmic thinkers, our universe is snugly nestled inside what they call a brain, short for membrane. Essentially, we're stuck on a stretchy surface capable of all sorts of cosmic gymnastics, contracting, stretching, oscillating, you name it. It's like we're hanging out on pieces of fabric on a cosmic clothesline. Now, imagine these parallel universes side by side, each with its own plotline. We're not an exception here, we're just one universe in this vast neighborhood. And get this, another universe might be just a hair's breadth away, but we can't see it because there's this tiny space keeping us apart. A minuscule gap in the cosmic tapestry. In the vast cosmos of ideas, that tiny space holds the fourth dimension. Now, let's talk about how these universes throw their own cosmic parties through brain collisions. Picture this, these brains, or cosmic membranes, are inching toward each other at a snail's pace. Then, one fine day, bam, they collide, birthing two Big Bangs and, you guessed it, two parallel universes. Now, they don't hang out forever. Nope, they drift away from each other, and life continues in these freshly minted worlds. But hold your cosmic horses, when they vanish, these brains get cozy again, setting the stage for a new universe. Remember the inflation theory? That mysterious energy that gave the Big Bang a serious push? Well, colliding with another universe could be the grand explanation for it all. But let's be clear, the idea of our world as a piece of fabric on a rope does sound like cosmic gibberish. Yet it's rooted in string theory and M-theory, the rock stars of quantum mechanics. Creating a theory is no cosmic cakewalk. Turok and Steinhardt did some serious brain crunching, trashing many non-starters along the way. Plus, they had to flex their mental muscles and think in 11 dimensions simultaneously. And guess what? This wild and elegant idea got its share of laughs. Turok and Steinhardt remind us that scientists are just regular folks, scared of change and the great unknown. Challenging established beliefs is daunting. Remember when people scoffed at the idea of a round Earth or the Big Bang? Discoveries come with struggle and fear. So, they're not throwing in the cosmic towel just yet. The evidence we have now puts these three theories on equal footing. Which one is correct? Well, in this chapter of human development, we're still in the theorizing phase. But who knows? Someday, some evidence might waltz in and lift the cosmic veil, unraveling the mystery of our universe's origin. But who knows? Someday, we may stumble upon that cosmic key that unlocks the secrets once and for all. Perhaps one day we will be able to untangle the threads of the mystery of the birth of the universe. And that's a wrap for today. If this cosmic journey satisfied your curiosity, enjoy it, share it with your colleagues, and stay up to date by clicking on these videos below.